This is a support video for the third year in National 4 Engineering Science Analogue Electronics work booklet. This is looking at task 1. And in task 1 we're asked to build the circuit that's shown in the right hand side of the screen. So to be able to do that we need to have first of all a battery to give us a power supply, and we can find that in the lab equipment folder inside power supplies, and we can get ourselves a battery. Quite important to notice that the battery is polarity sensitive, which means it has to be connected around the correct way. Now if you look at the little plus symbol that's on there compared to there, then you can see that our battery is currently around the wrong way. So if we click on it to select it and use the little handle to rotate it around, now we have it in the right orientation. We also need an ammeter so that we can measure the current in the circuit, and we can find that inside the measurement folder within lab equipment. Here's our ammeter here, and I can click and drag that into position. We also need 3 of these devices here, which are called lamps. If we go into electronic components, lamps are output devices, and they give off light as their output. So if I go into the light folder, then I can find signal lamps, which has got the correct symbol that I'm after, and I can bring 3 of these out from the components folder into our workspace. Having done that, I can now connect up all of the components in series so that they can form a continuous ring. And when I complete this last connection, then the battery will supply electricity to the circuit, which we can see the little black arrows are indicating that there's a current flowing around about the circuit, and the lamps are beginning to illuminate by turning yellow in our simulation. And that absolutely makes sense, because the function of a lamp is to convert an electrical energy input into a light energy output. Our ammeter is showing that there's a current reading of 30 milliamps. 30 milliamps is a fairly small current, which is absolutely accurate for this kind of circuit. And 30 milliamps is an absolutely acceptable reading for giving us the current that's flowing through this circuit. However, if you prefer to be more standardised and just to use amps, then if you can right click on the ammeter, go to properties and click in the auto range, then it will change it back to amps. So our standard reading is 0.03 amps, which is equal to the 30 milliamp reading that we had previously.